Today we will solve the problem 2.37 of Griffith third edition Introduction to Quantum Mechanics. The problem 2.37 is a particle in the infinite square well equation 2.22 has initial wave function psi of x0 is equal to a sine cube pi x over a between the limit 0 to a. Determine the normalization constant a and find the wave function which depends on time, that is psi of x and t, and calculate the expectation value of x as a function of time, and what is the expectation value of energy. First we will go one by one. First we will find the normalization constant. So by definition, normalization constant minus infinite to plus infinite modulus psi of x0 squared dx is equal to 1. So here the wave function, given wave function is this one, a sine cube. So this will become modulus a squared sine cube pi by a whole square dx, which must be equal to 1. Here limit is 0 to a because this wave function is valid between 0 to a. Now from trigonometry relation we can write sine 3 theta equal to 3 sine theta minus 4 sine cube theta. So from this we can rearrange the term and we will get 4 sine cube theta is equal to this 3 sine theta, and if you bring this to the other side, this will become minus sine 3 theta. So now you bring this 4 to the other side. This will become 354 sine theta minus this 1 over 4 sine 3 theta. So we will simplify it further. So now we have seen the sine cube theta is equal to 3 by 4 sine theta minus 1 by 4 sine 3 theta. So the given wave function is a sine cube pi by ax. So which will become by using this formula, you will get a I am taking out instead of sine cube theta. I am going to take it. I am going to replace by this term. So this will become 3 by 4 sine pi by ax and minus 1 over 4 sine 3 pi by ax because it's 3 theta. So we got this relation. And remember that for infinite square well potential, the wave function of nth state is equal to square root of uh, 2 over a sine n by a x. So use this relation. That is, we need here in front of this sine theta because given wave function is this. So what I am going to do is I am going to multiply this sine theta, both sine value by square root of a by 2 into square root of 2 by a, square root of 2 by a. So if you multiply both, you will get 1. So it will not change your expansion. This expansion will not get affected. So I am going to rewrite this psi x and 0 is equal to, here you have 3 by 4 and this, as I said, square root of a by 2 multiplied by square root of 2 over a sine pi by a x minus 1 over 4 square root of a by 2 square root of 2 pi a sine 3 pi a x. So here this is your wave function. This wave function is naturally psi 1 because here n is equal to 1. And what about this? This wave function is psi3, because here n is equal to 3. Then you have one parameter, square root of a by 2. So you take that out. A multiplied by square root of a by 2. Here you have 3 by 4 psi 1, and here 1 by 4 psi 3. Now we will try to simplify this. So now we got the initial wave function as linear combination of psi1 and psi2 with the expansion coefficient 3 by 4 and 1 by 4. So the initial wave function is a multiplied by square root of small a divided by 2, 3 by 4 psi1 and minus 1 over 4 psi 3. Now to find the normalization constant, the integral between minus infinite to plus infinite, modulus square of psi x 0 must be equal to 1. Now psi x 0 is, you replace this, you will get a square. If you square this, you will get small a by 2, and this integral 3 by 4 psi 1 minus 1 over 4 psi 3 modulus square. So if you take modulus square of this integral, then you will get psi 1 stars psi 1 is equal to 3 by 4 into 3 by 4, which is 9 by 16 uh, modulus psi 1 square. Similarly for psi 3, this is equal to uh, 1 over 4 psi 3 star into 1 over 4 psi 3, which will become 1 over 16 modulus square of psi 3. Then this cross term minus 3 by 16. You can see this is 4 into 4, you will get 16. Psi 1 star psi 3. Then another cross term is psi 3 star psi 1, and multiply this coefficient. 3 by 4 into 1 by 4 is equal to 3 by 16, which must be equal to 1. Now, due to orthonormal property, this will be 0, because psi 1, psi 3 are independent. So, this also. Last two terms will be 0. Then you will get non-zero term only the first two one. So, this can be written as modulus a squared small a by 2 integral between minus infinite to plus infinite 9 by 16 modulus psi 1 square, then plus 1 over 16 modulus square of psi 3 tx must be equal to 1. Now we will find the value of a. Now we got this integration. Uh, that is, if you integrate this modulus psi 1 square x with respect to t x, then you will get 1 integral between minus infinite to plus infinite. Similarly, modulus psi t square, if you integrate between minus infinite to plus infinite, modulus square of psi 3 is also equal to 1. So naturally, this integral you will get a squared multiplied by a small a by 2, then 9 plus 16, 9 divided by 16 plus 1 divided by 16. In the numerator you will get 9 plus 1, 10 divided by 16, and modulus a squared small a by 2. This, if you cancel this, you will get 5. In the numerator you will have 5a, in the denominator 16. Of course you have modulus a squared, which is equal to 1. That means modulus a squared is, if you bring this to the other side, you will get 16 divided by 5a. That means a is equal to, if you take square root of numerator, you will get 4, and the square root of denominator is square root of 5a. So we have found the normalization constant 1. Now next our aim is, we have to find the time dependent wave function. So we know that initial wave function psi of x0 is equal to a multiplied by square root of small a over 2, 3 by 4 psi 1 and 1 by 4 psi 3. Now you add this time factor here. So we have to find the time dependent wave function. So here it is e power minus I e1 t over h cross. Here it is e power minus I e3 t h cross. Here you can cancel some of the term. Square root of a will get cancelled with the square root of a, and in the here and 4 will get cancelled with this 4, and here you have 4 will get cancelled. So in the denominator you will have square root of 5 into square root of 2, which is square root of 10. That is 1 over square root of 10. We have cancelled this 4. So naturally this will be 3 psi 1 e power minus I e1 t over h cross minus psi 3 e minus I e3 t over h cross. Now we got this time dependent wave function. Now we have to take the modulus square of this one. First you take modulus square of self term, that is 3 psi 1 e power minus I e1 t over h cross. Now if you take psi 1 star psi 1 star psi 1, then you will get 3 into 3 9. Then if you take complex conjugate of this e1 exponential term, then it will become plus. So e power plus I theta into e power minus I theta equal to 1. So you will get 9 psi 1 square. Similarly for this, you will get psi 3 squared. Second one. Now you take the cross term, that is psi 1 psi 3. So you will get 3 times psi 1 this psi 1 star, because we are taking psi 1 star, that is psi 1 into, if you take complex conjugate of this one you will get it plus. Then psi 3. Psi 3 is equal to psi 3 e power minus I e3 t over h cross. Same thing apply here. Psi 3 star is equal to e power I. This will become plus I e3 t over h cross. Of course, this psi 1. 3 times psi 1 e power minus I e1 t over h cross. Now you leave the first two term as it is. Then you can take third term. This and this. You can rewrite this. You take minus outside. Then this will become plus e3 and minus e1 times t divided by h cross. Same thing here you can see this E3 is a positive quantity, so E3 minus E1 T over H cross. Now you take this 3 psi 1 psi 3 as common, 3 psi 1 psi 3 as common. Then you will get e power minus I e3 minus e1 t over h cross plus e power plus I e3 minus e1 t over h cross. So e power minus I theta in plus e power plus I theta is equal to 2 cos theta. Applying that formula, you will get, you multiply this 3 into 2, you will get 6. 6 times psi 1 psi 3. This is cos e3 minus e1 over h cross t. So this is the modulus square of the time dependent wave function. Now we got the modulus square of the time dependent wave function psi x and t like this. So now in order to find the expectation value, you integrate between minus infinite to plus infinite x modulus square of the psi which depends on x and t. Now you replace this modulus square of psi x and t by this one. So you will get, first one is x first integral will become x psi 1 star squared dx, first integral. So what will happen? This is the expectation value of x. In order to indicate this is the expectation value for wave function 1, I am using subscript 1. So this is 9 divided by 10 because I am bringing this 1 over 10 inside. The expectation value of x1. Similarly here, 1 over 10, the expectation value of x cube, and this term, that is third term, cross term, you will get 1 over 10. If you bring 1 over 10 inside, then this will become 3 over 5 cos E3 minus E1 over h cross t. Then you integrate this cross term, x psi 1 psi 3 dx. So now you know x psi 1 is this one, sine pi by ax, and psi 3 is sine 3 by a x dx. We have to find. Here you can use the formula sine a sine p is equal to sine a sine p is equal to 1 over 2 cos a minus p by 2, cos a by p, sorry, cos a minus p plus, sorry, not plus, it is minus cos a plus p. Of course, this half is inside the bracket. Everything will come inside the bracket. So applying that formula, this 2 and this 2 will get cancelled. Then we can rewrite this as x multiplied by cos a minus p. That is cos a minus p is minus 2 pi. Cos is a even function. So you can very well write this as 2 pi over ax, and this will be a plus p. So this is 4 pi minus cos 4 by divided by a x dx. Now we have to find the third integral. First two we have already solved. This thing you keep it in your mind. That is, first two we have already calculated. Only the third term, third integral we are going to solve. So now we have separated that integration into two parts. That is 1 over a integral between 0 to a x cos 2 pi by a x dx minus 1 over a integral limit between 0 to a x cos 4 pi divided by a x dx. So the integral part is a standard integral. Integral of 0 to a x cos px dx is equal to x divided by p sine px plus 1 over p squared cos px. So here in the case of first integral, p is equal to 2 pi a 2 pi a x. So here if you apply the upper limit, then you will get, if you replace x by a, you will get sine 2 pi, which is 0. Then lower limit, sine 0 also 0. Then you come to second integral. Second integral, you have p is equal to 4 pi divided by a x. For upper limit, this will be 4 pi. So sine 4 pi is equal to 0. Lower limit 0. So for fourth integral, this term will become 0. Then what about the second term? The second term cos px. For first case, this is 2 pi by a. For upper limit, this is equal to, for first integral, upper limit is equal to 2 pi. So cos 2 pi is equal to 1. If you apply lower limit, cos 0 also 1. 1 minus 1, you will get 0. So for first integral, this term will be 0. What about second one? Second one, for upper limit, a, cos 4 pi is 1. Cos 4 pi is 1. And for lower limit, cos 0 also equal to 1. 1 minus 1 is equal to 0. So both the cases, this term will get 0. So naturally the entire integral is 0. So now we have seen the expectation value of x is equal to this one. Now this integral third term will be 0. We have seen this is 0. So only first two term exist. 9 over 10 expectation value of x sub n is equal to, for infinite square well potential, this is a by 2. So I can replace this a by 2. Similarly, this I can replace the second term 1 over 10 x3 expectation value of the third level also a by 2. So a by 2. Now you can see here 10 into 2 20, 10 into 2 20. So numerator is 20 for both term. Sorry, denominator is 20. Numerator is first one 9a plus 1a. So 9 plus 1 a. So 9 plus 1 10. So you will get this 10 divided by 20 is 2. So this will become a by 2. So the expectation value of x is equal to a by 2. Now we have to find the expectation value of energy. That is the expectation value of Hamiltonian, which is equal to modulus C1 squared E1 plus modulus C3 squared E3. This C1 squared, modulus C1 squared is 9 over 10, and E1 is n, since n squared is equal to 1, this will become pi squared h cross squared over 2ma squared. Next, modulus C3 squared is 1 over 10 we have seen. And E3 is equal to 3 squared, n squared is 3 squared, 9. 9 pi squared h cross squared over 2ma squared. Now you can rearrange the term. Here in the first term, in the numerator, you have 9 pi squared h cross squared. In the denominator, there is 10 into 2, 20 ma squared. Then the next term, numerator, you have 9 pi squared h cross squared. In the denominator, 10 into 2, 20 ma squared. So you can take 9 pi squared h cross squared over 20 ma squared as common. Here you will get 1 plus 1. 1 plus 1 is 2. This 2 will get cancelled with this 20. You will get 10. So the expectation value of Hamiltonian is 9 pi squared h cross squared over 10 ma squared. This is the expectation value. So we have answered that also. Thank you very much for watching my video and supporting me continuously. Thank you very much.